Yeah, I'm kind of going to be a surrogate Jody because I've worked with Jody for years and kind of encouraged her to work with Rob. So I just want to let you know a little bit about what we've been doing and what Jody does do so you can see how it might fit into some of the, I kind of wish the EPA woman was here about. So Jody is at the University of South Florida where I used to be, and she works on water quality issues associated with microbiology. And she and I have had some projects for a number of years to do with how environmental parameters interact with microbial communities to affect the growth and survivorship of different microbial organisms. And then recently we have started working with Rob through this project to expand some of that work. And Chris Cornelison is at the Cawthron Institute, and he works with us as well. And essentially we use stable isotopes to track terrestrial inputs of nutrients and things like that and match it with microbial ecological processes. So Jody asked me just to give you a brief overview of what she does because she's been brought in on this project with Rob, and she wanted people to know what she does. So essentially, when you talk about water quality, you have all kinds of inputs, and some people brought up these kinds of questions in the last talk. So you can have cows, you can have dogs, you can have people, you can have all kinds of things whose activities and sewage can end up in the water quality body. And how do you identify, especially when we go out and say there's a lot of E. coli, say, in this water column, but we don't know where it came from. So there's all different kinds of pathogens, and there's viruses, there's protozoans, there's bacteria, and many of these are, what we've done is picked out a few of these, and primarily E. coli and a couple of other bacteria as indicator bacteria. And generally they're non-pathogenic, and one thing that's really interesting is they don't necessarily have the same ecology as the pathogens. And so what we've been working on is ecological processes that affect survivorship of indicators versus survivorship of some of the pathogens. And this particular work that she's looking at is how do you identify which organisms these different organisms are coming from. So indicator organisms have been used to kind of indicate that there's pollution. And primarily in the past, we've just been doing plating and seeing how many organisms are there. But there's some real drawbacks, and some of it is there's false negatives, the ecology is very different. There's false positives, and we really don't know whose E. coli it is. And that's one of the biggest things, is when you go out into the beach and you find a whole bunch of E. coli, like this happened in Coyote Bay, and you find a whole bunch of E. coli at the north side of the bay near a pool or a ranch. There's a question of whether that is human sewage or cow. And nobody here in Hawaii is actually doing some of this kind of work, which could have identified exactly whose E. coli they are. So what this work does is look at the source. And the sources are going to indicate a number of things. One is what kind of risk there is. If it's cow manure, it's not the same risk as if it's human manure. And it does help you with remediation and know where the source is and what to do. So the essential question of microbial source tracking, which is Jody's strength, is who is the pollution from? Is it from the birds, the dog, the cow, I think that's the cow, or the humans? And so what's interesting about this technique is there's microbial species are associated with the intestinal tracts of different organisms, and many of them are shared. So, for example, you might have the same intestinal organisms as your dog and your cat and whatever, but there are certain ones that have been found to be associated with just certain species. And so, like a sheep, for example, may have one that's very different from humans. But the interesting thing about it is a sheep in Hawaii may be very different than a sheep in Florida. And a sheep in Hawaii may be very different than a sheep in New Zealand because they've been exposed to different interactions and all that kind of stuff. So you actually have to go to a site and collect poop of all these different organisms and find out what is specific to that organism in this site. So it's is not good enough just to go and say, oh, this is sheep. You actually have to do it again in each site. You can identify some genetic markers that are on the genome of these bacteria in each location. So you would have to go to Hawaii, you would have to go to New Zealand. You can find the genetic marker for cow, for example, and then go and take an environmental sample and run that sample and be able to determine if it's cow poop or sheep poop or pig poop or whatever. So Jody is very much into poop. She has many pictures of herself with poop. But what her technique is, which she is now, and Zoli's going to talk about it, is I heard Zoli's talk last time, and I said, you know, this would really help and really add to your stuff. So I asked Jody if she would be interested in participating. So basically what you find is you can look at pigs, cows, everybody, you can collect their poop in a location, and you have to do it in a location, and you can get these markers. They're not perfect, and so there's still some questions about sensitivity and validation, but it does allow you to locate or identify primarily who it's from. There's different targets, which I don't really need to tell you about, so they'll probably tell you more about that. And then some of the future work is to develop all these kinds of things. And one of the things we're really interested in around here is to better understand the ecology and persistence of organisms, like different types of organisms, and how environment and things like sand, dirt, algae help the difference in survivorship of different groups. And the terrestrial nutrient sources, which Jody and Chris and I are working on, to look at linking terrestrial sources and information about isotope information with microbial source tracking.